is 9.4. It's a composition of transformations. Okay, so we're doing multiple transformations at once. So the pattern of footprints left in the sand after a person walks along a beach illustrates the composition of two different transformations, translations and reflections. Okay, so when a transformation is applied to a figure and then another transformation is applied to its image, the result is a composition of transformations. So at the right there in that picture, I know it's kind of hard to see, but they are footprints in sand. So from one footprint to another, that would be a translation, so sliding up, and then it can reflect over that line. Okay, so it has that slide and then that flip. Now, glide reflection is the composition of a translation or a slide followed by a reflection in a line parallel to the translation vector. Okay, so your translation vector goes in that straight line, and it has to reflect over a line parallel to that. Okay, not sideways or diagonal. The glide reflection shown is a composition of a translation along vector W followed by a reflection in line L. So they're talking about this picture here. So first, we're moving that foot along that vector W to get this one right here. So that's your first image. Your second image is then this one right here reflected over line L. So you have to do one, get the image, and then do the second one to get that next image. Okay, so not too bad. So what we're going to do next here is our own glide reflections in the graphs below. Okay, so we have triangle PQR with the following vertices, and we want to graph PQR and its image after this indicated glide reflection. So in our directions here, first thing stated is what you're going to do first. Okay? Don't read from the bottom and up, read from the top down. Okay, so first thing listed is what you do first, and then followed by that second thing listed. So first thing we want to do is plot our original points, so P, Q, and R. So point P is at 1, 1. Q is at 2, 5. And R is at 4, 2. Okay, so this is your pre-image. Okay, the image you're starting with. It's your pre-image. Next, what we want to do is this translation along this vector. Now this vector tells me I'm going to move each of those points left 2 units. Okay, and then that 0 indicates I'm not moving up or down. So from each of these points, I'm just going to move left 2. So I have 1, 2, and I can plot that point, label it P prime. Move Q left 2, that will be Q prime. And R left 2, that is R prime. And then connect all 3. Okay, and what I'm going to do off to the side is just label each of those prime coordinates. Okay, so P prime is at -1, 1. Q prime is at 0, 5. And R prime is at 2, 2. Now from here, for our second transformation, that is a reflection in the x-axis. Okay? Now when you're doing this transformation, you need to use your prime coordinates. Don't go back to the original and reflect that one. Use the ones you just found and reflect those in the x-axis. So we'll take point P, and we want to reflect it over this x-axis here. That's 1 unit away. So go 1 more unit away, and that will be P double prime. Okay, same thing with Q. Okay, point Q is 5 units away from that x-axis. So I'll go 5 units in that opposite direction for Q double prime. And then R prime is 2 units away. So 2 units in that opposite direction for R double prime. And I can connect all 3. Okay, and then this would be your final image. Okay, so again, you want to go from your original, do the first thing listed to get your prime coordinates. Okay, after you do that, you can do the second thing listed using your prime coordinates to get your double prime. Okay, don't go back to the original coordinates to do that second thing listed. So now I can write out my double prime coordinates off to the side here. So P double prime is at -1, -1. Q double prime is at 0, -5. And R double prime is at 2, -2. Okay, questions on how I did this glide reflection or that composition of transformations? All right, then I want you guys to do letter B. For letter B, you're still using the original as P, Q, and R that was given in this directions here. Okay, so plot those points first, complete this translation, and then this reflection. All right, so for letter B, from your original right here, you wanted to move left 3 and then down 3 to get these prime coordinates here off to the side. And then a reflection in the y equals x line. That means you're switching x and y, okay, in your original coordinate. So from my prime coordinates, I just want to switch x and y to get my double prime coordinates. And I can plot those to get that final image. Questions on that? Okay, and you can see that it's kind of hard to tell where some of your points are for your double primes because of that reflection. Okay, that's why I like to write my coordinates off to the side so I know I actually have it correct. Okay, so next here, the composition of 2 or more isometries is still an isometry. Okay, so it's still keeping its same size and same shape. It's not getting larger or smaller, and it's not adding on extra points to change its shape. Okay, it stays that same shape, it just does move around. So in example 2, this one is not a glide reflection, okay, but it is still a composition of 2 transformations. So the endpoints of segment CD are at these 2 coordinates here. First, we want to graph segment CD and its image after first a reflection in the x-axis and then a rotation of 90 degrees about the origin. Okay, so again, reading it in order. So first we want to graph segment CD. Okay, so point C is at -7, 1. And point D is at -3, 2. Okay, so here's that segment CD. Now our next step is to graph that reflection in the x-axis. So x-axis is right here. And again, all we have to do is count. So from point C, it's 1 unit to that x-axis. So I'll go 1 more unit away to get C prime. Point D is 2 units away from that x-axis. So I'll count 2 units further to get D prime. Okay, so here is that segment. And off to the side, I do want to just label those coordinates. So C prime is at -7, -1. And D prime is at -3 and -2. Okay, our next step is this rotation of 90 degrees. Okay, and that rule is opposite of y, x. Okay, so this is our rotation rules that we went over a few days ago. Okay, opposite of y, x. So now to change each of these to those double prime coordinates, again I want to use my coordinates I just found for this next part. We're going to take the opposite of y, so since it's -1, it will now be 1, and then leave x the same, and x was -7. Okay, and then to get D double prime, again looking at your y value first, we want to take the opposite of what it is. So since it's -2, it'll now be +2. And then we want to leave x the same, so it's still at -3. So next I can plot those 2 points. So we have 1, -7 for C double prime, and then 2, -3 for D double prime. Okay, and that's where that segment would end up. That is your final image. Okay, questions on this? Alright, so I want you to flip it to the back then. The composition of two reflections in parallel lines, okay, so these lines have to be parallel, is the same as a translation. Okay, so once you reflect twice in parallel lines, it will just look like it slid over or it has that slide to it. Okay, so in that picture below, this is your pre-image right here on the left. It's reflecting over line K to get P prime. Okay, you can see that reflection. And then reflecting again over line L, which is parallel to line K. Now if you look at your pre-image and your final image, it does just look like it slid to the right. Okay, so it does just look like that translation. Another one we have here, the composition of two reflections in intersecting lines. So this time they're not parallel, they do intersect at one point, is the same as a rotation. Okay, so when they're parallel, you have a translation. If they're intersecting, it's a rotation. So from our original, that one's right here, segment A, reflecting over line K to get A prime up here. Okay, once it reflects again over line L, which intersects line K at this point, you get your final image right here. And if I go from A to A double prime, it does look like it rotated around that intersection point of those lines. Okay, so two reflections in intersecting lines is a rotation. So I do want to practice that in the pictures below here. Now these don't have to be perfect because mine are not going to look anywhere near perfect. Okay, so first in letter A, we want to reflect over line N and then reflect over line Q. Okay, so we'll reflect the smiley face here over line N. Okay, and when I do that, the eyes will be down here and the mouth will be up there. Okay, that's one reflection. And then we want to reflect it again in line Q. Okay, and when I do this one, it does look like it just slid down over those lines. Okay, so that looks like a translation. Okay, so this is something to kind of just keep in mind for our Desmos activity tomorrow. Okay, then letter B, this is our intersecting lines. So again, first we want to reflect over line N and then line Q. Okay, so reflect it over line N first. Okay, and then reflect it over line Q. Okay, and then it does look like it rotates around that intersection point of those two lines. And again, it does not have to be perfect. So that one does look like a rotation from your original to your final image. Questions on that part? Then looking at these patterns below. So many patterns in the real world are created by using compositions of transformations. So with those leaves below, it's kind of like our footprints from the beginning. So first what it would do is translate, so slide to the right, and then it would reflect over that line to create that new leaf. Okay, so it slid to the right, then reflected, and it'll keep doing that same thing over and over. So it would slide to the right and then reflect again. Okay, so that's how these patterns are created. So the last two problems here, I want you to describe the transformations that are combined to create each carpet pattern shown below. Okay, so you can talk to the person next to you, but I do want you to come up with a combination of two transformations that would create that pattern.
Yes.
So it has to be like All right, so for carpet pattern A, I said it could be a reflection and a rotation. Okay, so it could reflect over a line to create that other, to create a full diamond shape there, and then it could rotate around that center point, okay, to create that circle. For B, I said a rotation and then a translation. Okay, so I rotated this shaded piece to this other one. Same thing with the non-shaded piece, rotated it to the other one. And then this whole entire square segment here could be translated across. Okay, so you should kind of be looking at those patterns to see, oh, they moved it here and then there. Okay, questions on any part of this note sheet? So again, when you're graphing, make sure you write out your prime coordinates and your double prime coordinates. Okay, so after you do your first transformation, okay, so that first transformation you get your prime coordinates. Then your next transformation, you need to use your prime coordinates to get your double prime coordinates. Okay? On your assignment, you're going to see just a lowercase r and then a subscript of what you're going to do. That lowercase r means reflection. Okay, so you're going, for number 1, you're going to reflect it in the y-axis. Okay, it does not mean rotation about the y-axis, it means reflection. Okay, rotation about the y-axis would be silly. So, lowercase r means reflection, not rotation.